Okay. So here we are, fourth block physics, Tuesday, September 15th. All right, so you all should have got the assignment from the book. Good? So, and of course, hopefully you all saw that yesterday either on the video or, so here's how I want, when you do like, where you're gonna have to write answers like on a sheet of notebook paper, make sure, and I cannot emphasize this enough, that you draw a line, put your answers here, put your work here. So for example, like on number 14, you got 9, and I ran out of room, but let's say if I were to do this on a big sheet of paper. So you've got 9.12 microseconds, and you want to convert that from microseconds into seconds. So like, here's this line on your paper. So here's 14A. Now, keep in mind, this is going to sound egotistical, but this is all about me, okay? I want to be able to see exactly what you have done in terms of cancellations, your work, things like this. So, you're going to convert this into seconds. So if you look on your handy dandy equation sheet number 1, over here you've got microseconds, which is 10 to the negative 6. So there's a microsecond is a very, 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 very small measure of time. So if you come down here and go, okay, hey, 1 microsecond is 1 times 10 to the negative 6 seconds. So if I multiply that across, now if you did this one, you don't have to put, if you really want to put this into your calculator, you can. It's just 9.12 times 10 to the negative 6. So if you really want to plug that in, you can. So your answer to 14A is just 9.12 times 10 to the negative 6 seconds. Okay, that's all. But then, here's the deal. When you do B, again, this is all about my perspective. Don't cram everything into one big problem where I can't figure out where one problem starts and or one stops and the other one begins. So then, like, here's your answer to B, have that work over here. Okay, so just, I beg of you, leave me space, write big. So when you guys send this in, okay, so you're going to have like your name, and then you guys are in fourth block, so you'd have like Smith 4, and then you would have like assignment 1-1, because that way I know whose it is, I know you guys are in fourth block, and then I know what assignment that is, because I've got to keep track of like assignments from you guys, from my third block class, from my first block class, who's handing what in. This is just a matter of me keeping it easy. So, does anybody have any specific questions on that assignment from the book that you want me to go over? You're good. There's none whatsoever you want me to go over. You're completely confident on all of them. Now, I never remember. Do they give you the odd answers and even answers in the back of the book? Sort of looking at the back of the book, because I can't remember. I think they give you the odds, if I remember right. I think they give you the odd answers.
Yeah.
Okay. So, let me give you a hint. Your answer to number 20 should be around 2 meters. Okay? If you did that right, that's around 2 meters. Because on 20, you kind of got to do some different conversions, because I think that's the one with like the pole vaulter. So your answer to number 20 should be around 2 meters. And then your answer to the most complicated one on 16 was C. So if all goes well on 16C, your answer should be something times 10 to the 7th seconds. So on 16C, you should have something times 10 to the 7th seconds. Okay? If all goes well. All right. We're good? Going once, going twice. So hopefully by about 6 o'clock today, you all can get that scanned and sent to me, and then tonight, I should be able to get, tonight is my night to catch up with you guys on grading. So I'll get like that lab and the dimensional analysis done, and then get that back to you guys tomorrow, because last night I was spent on my first and third block classes. So tonight, you guys get my grading done. All right, so here's what we're gonna do. We're gonna go out into the hallway. You guys aren't gonna get to see this. Oh yeah, we'll take the camera out. Okay, Rachel, we're gonna have you take the camera. Okay, I wanna do this outside. We're gonna have to take two. Yeah, we'll roll the dice. Okay, so for those of you that are zoomed in, it's going to get a little bit sketchy because we're going to have somebody like hold the camera and the laptop at the same time. Okay, and for those of you that are watching on the YouTube video, we're going to have somebody holding that camera as well. So we're going to go out in the hall. Okay, Janine, I need you to grab that big camera. Okay. Rachel, I'm going to have you grab this laptop and bring that with it, okay? And then I need you guys, like timing, and because we're going to see how long it takes for me to run 10 meters. So, this is going to be a team effort. So, all right. And the camera is just like collapsing. Okay. So, you got that?
Okay.
So we're going out in the hall. And then you take that. And then you got to remember that's the direction the camera is pointing. Okay, got it? Okay, let's go. Now, when we do that, I want to keep the whole this end of the tape, and then I want to need you guys to time. Got it? Oh,
No,
catch that.
Kelsey.
Stopwatch down. Okay. So you walk that way. Whoa, slow down, slow down, slow down. Wait.
Which video?
9, 10. Okay. Let's lay that down. Okay. So here's what's going to happen. And you ladies, this is just, all you're going to see is like a green blur go by. Okay? So a 54-year-old man is, with high cholesterol, is going to run 10 meters. So this is the distance. We're going from that to that. Okay? You guys are going to time it from when I cross that point to the point that I get down there. Okay? Bless you. Got it. So we got both of you ready to go? Now, what's going to be important here is that I'm going to already be moving when we start this. I'm not going to start from rest because we're going to use this idea that distance divided by time is going to get my velocity. But that only works if you're moving at constant velocity. So I can't start from rest, speed up, and then try and take distance and divide it by time to get velocity. So that will play out large later on. Distance divided by time is a lovely equation, and we're going to use it a lot. But you can only use it when you're moving at a constant speed. Okay, so trying to do this without killing myself. Okay, so timers, you guys ready? I don't want to do this twice. My heart can't take this. Okay, you get one shot at this. Okay. Physics teacher passes out after running 10 meters in high school. Okay. You ready? Cameras, are we ready? Okay, all right, here we go. It's just a blur of green. I know that's all you saw. Okay. So what did we get for times?
I got 2 seconds exactly.
Really?
Yeah.
I got 1.47.
Okay. Now, do you think this is how they time like world records at the Olympics? Yeah, no. So this is a situation where if you look at this idea of significant digits, we had a pretty good idea of the distance. 10.0. We're not saying it's 10.00000. We laid out a tape measure. It was about 10 meters. Okay? we had about a half a second variation in the time. One was exactly 2 seconds, and one was 1.47 seconds. That's off actually by quite a bit. So we've got some sketchy data, right? Man, that is true. I mean, it isn't like, you know, hey, this is how they timed the Olympics, and you got one guy, this is only over 10 meters. Imagine if it was like a 100-meter dash, and you got guys going, okay, start, and they're about halfway through, and they're going, okay, I think they crossed the end, stop, all right? And they've got lasers and everything else set up. Okay, got that. All right, so let's go back inside, and we'll look at the data now. So,
You can't set this up. I'm gonna guess.
Think about your time, it was like 4 seconds off. That would be
Tina, help me.
attention.
I'm not very good.
pretty good?
It's a little low.
I should be able to tilt it up a little bit.
Is that a whole